Well, we've already parallelized our raw input data into our starting RDD, which is called original log messages. So the usual way of setting up these data structures is to set up an initial RDD with your raw data, and then to start doing some transformations on that data to convert it into the data structures that you need. I hinted about this in the introduction chapter, that Spark is very clever at organizing the jobs that you need to do, the transformations that you're applying, and Spark's very clever at organizing them into an efficient execution plan. We'll be talking in a lot more detail about that when we get to the chapter on performance. But for now, I hope you're comfortable with the idea that given our raw RDD, it's a very common thing to go ahead now and to transform this using some of the methods that we've seen previously, such as map or reduce. We're going to transform it into the type of structure that we want. So we want one of these new PairRDDs. And there is a method to do exactly that. I hope you're familiar now with the concept of the map method, which will transform an RDD by applying a function to each row or each value inside that RDD. But there is also, if I go a little further down, there is a method called map to pair. And that allows us to take an RDD which might look something like this, and we can transform it into an RDD that looks like this. So you're familiar with how maps work now. This is going to conceptually loop around the original RDD, which contains these values, and it's going to one by one serve up that, I'm going to call it the raw value. And it's our job to do something with this raw value. And I think just for illustration, I'm going to split this function onto multiple lines. Now, you haven't seen me do this so far. Again, it's another part of the Java Lambda syntax. Generally, so far, we've been doing everything on a single line, but there's absolutely nothing to stop you having more complex functions that span multiple lines. And to do that, we use a curly bracket block, just like this. And in fact, I'll complete the line there by adding the semicolon on the end so I don't get confused. And I can now put as many line breaks as I like in between those curly brackets. So we can do several lines of code inside this Lambda function. And I'm doing that because for these raw values, I want to split them. I want to split them into the log level and this date and time. You probably know from standard Java that given a string, there is a method on a string called split. And that allows me to pass in as a parameter, well, in fact, it's a regular expression, but that's only if you get complicated. We can just specify the character that we're splitting on, which for us in this example is just a simple colon. Now, I've been very careful to make sure colons don't appear anywhere else in these logging messages. And what this will do is it will return an array of strings. So I'm going to call those, let's call them columns, because they kind of feel like columns in a table. So we're going to have then, for the logging level, is going to be the first element in this array. In other words, in Java speak, that will be the 0 element. And then for the date and time, I'll just call it the date. That's going to be columns 1. And then we're nearly finished. We've got the level, which is going to be the key for this PairRDD, and we've got the date, which is going to be the value. So all that remains is we need to return the key value pair. And how do we do that? Well, these PairRDDs work using tuple2s. So back to the caption. The key is going to be the first element of a tuple2, and the value is just the second element of a tuple2. And that's why I really had to tell you about these tuples, because if you want to work with these PairRDDs, and you will want to, then you've got to understand how tuples work. Hope you're familiar with tuple2s by now from the previous chapter. That just means I need to return a new instance of tuple2, passing in, first of all, what we're calling the key, which is the level, and the second value will be the date. Now, as usual, we have a warning here, which is we haven't used the generic on the tuple 2. So this is going to be for us a string and a string. Now that's got rid of that warning, but we now have another warning, which is a very confusing one. The warning we're getting, we've actually seen this earlier in the course, it's warning that the SC, which is the Spark context, is not closed at this location. Now we know we're closing it here, but clearly the compiler is believing that there may be a possible resource leak as a result of returning out of this lambda. Now, as far as I know, there's absolutely no problem here. It's just one of those confusing, noisy warnings that doesn't really mean anything. I must admit, this is something that I don't personally understand, and in all the research I've ever done on this, I've never found a satisfactory answer why we get this warning here. Perhaps if you know better, drop me a line, but I can promise you it's not important. And at this point, and I very rarely do this personally, I don't like these suppress warnings. I hate the fact that you see them scattered all over Java code everywhere. But on this occasion, in fact, if I follow the suggested fix here, it will actually put a suppress warnings on the main method here. So it doesn't kind of get in the way of the code. You won't even see or feel that. But it just cleans up that noisy warning. And without doing that, we'd probably have several of those warnings. And the problem with noisy warnings is that you tend to then start ignoring all warnings. And that's a problem because, as you've seen so far on this course, these warnings are actually useful when you forgot to put generics in and so on. So I'd rather make that go away just so that when I get warnings in the future, I know that it's something that I really do need to pay attention to. Anyway, I don't want that to get in the way of the learning, which is using this block of code, we've now taken our raw data and we've converted the RDD into one of these PairRDDs. So I mustn't forget that on line 33, we now have, and I haven't told you this so far, but the type of RDD now is Java PairRDD. So I'll call this new object PairRDD. Now, the second I did that, I've got an alarming looking set of errors, but don't panic, all very simple to fix. First of all, Java PairRDD, first time we've used it, so I will need to import it. As usual, if this is the first time you've done this, do check your import's correct. Java PairRDD coming from the Spark Java API. That's good. But I'm back to a warning again, and the warning is, yeah, we should be parameterizing all of this, definitely. Now, we know now that this PairRDD contains tuples. Each of these rows is a tuple. The key is just the first element of the tuple and the value is the second element of the tuple. But this is kind of one good reason for using these PairRDDs. I don't have to worry about the tuple here in the parameterization. A simplification provided by the API is, in the generic here, I just have to specify what the type of the first element of the tuple is. Well, for us, that's a string. And the second element of the tuple is also a string. So that does simplify things a little bit. The Java PairRDD takes it as read that we are working with a tuple here. So once I've done that, now the warning is just reduced down to, well, it's just warning us that we've never used this PairRDD. So we're going to fix that in a moment. One little simplification though, you might have spotted this on line 40. We can remove the string here because that will be inferred from the original declaration. So let's just try that and hope you can see there's no new errors, there's no new warnings.